Hello friends, today we are going to see how to segregate positive and negative elements in an array. So let's see what does that mean. See, if this is the array, then we have to collect all the negative elements together and all the positive elements together. So see here, for example, in this array, see, all the negative elements are collected together and all the positive elements are collected together at the other side. So this array has been converted into this array in which we have segregated positive and negative numbers. Okay, so let's see how to do this. You have to follow some steps and those steps are written here. Okay, and this is the code for these steps. I will explain you the code as well as these steps. Now first you have to use two variables. One is I and the second variable is j. I will start from the beginning and j will start from the end. Okay, means I will go on incrementing and j will go decrementing. Okay, now see here, increment I for a of I is less than 0. See, the basic principle is that all the negative numbers are less than 0. Okay, as you know, negative numbers are less than 0 and positive numbers are greater than 0. Okay, so in this case 0 is the pivot. If you remember quick sort, then you know the pivot element means all the negative elements will be on one side of the pivot element, that is 0, and all the positive elements will be on the other side of 0. So what is the first step? See here, increment I for a of I is less than 0. Okay, so check what is the element at ith index now? -1. So -1 is less than 0. Yes, it is. So you have to increment I. So I increment I, so I will become 1 now. It was 0 at first, I have incremented it, so it has become 1 now. Okay, now again see whether a of I is less than 0. No, it is not. Okay, because 3 is greater than 0. So if it is not, if this condition is not satisfied, so in the else you have to stop. So stop I here. Okay, in short you have to keep incrementing I till a of I is less than 0, else you have to stop. Then go for j. See, the step is decrement j for a of j is greater than 0, means you have to keep decrementing j till a of j is greater than 0, else you have to stop. So see whether 40 is greater than 0. Yes, it is. So you decrement j. Whether 30 is greater than 0. Yes, so you decrement j. Now whether -20 is greater than 0. No, it is not. So you have to stop here. Okay, now I has stopped here and j has stopped here. Now the third step, you have to swap both the elements a of I and a of j. So now you have to swap I and jth elements. So 3 and -20. So 3 will come here and -20 will come here. So we have swapped the elements. Okay, see, this is the code for these steps. See what the code says, I is beginning from 0, j is beginning from the end, that is n-1. So while 1, see, while a of I is less than 0, okay, you have to keep incrementing I, and this condition I is less than j. This condition is for avoiding the index out of range error. Index out of range. Okay, see, the compiler gives index out of range error if I goes ahead of 9, means I goes to 10. There is no 10th memory location for this array. There is no 10th memory location for this array. Only 9th memory location is present, means only 9 indices are present. So for 10 it will be out of range. So this condition prevents that, because whenever I goes greater than j, we stop the loop. Okay, that is why this condition works there. Then while a of j is greater than 0 and ai is less than j, see, if we keep decrementing j and if j takes -1 index, if j takes -1 index, then again it is the error, out of range, means no -1 location is present. So this condition again takes care of that. Okay, so as you know, you have to keep decrementing j till a of j is greater than 0. After you do this and after you stop at I and j, now you have to again check whether I is less than j and you have to swap. Okay, so this is the swapping step. Now you have swapped the elements, else you have to break. I will tell you this break condition as we go further in this execution. Okay, now here is an important step. Okay, see here, if you go in the next iteration here, again you will compare a of I less than 0. So a of I is -20, so you will compare -20 is less than 0 or not, but it is not necessary, because as we have swapped this I and j, now you can increment I and decrement j. As you are sure that I and jth element satisfy the condition, before going to the next iteration you have to increment I and decrement j. So here was I and here was j. Now if we increment it, so increment I, here I is incremented, and decrement j. Okay, so j is decremented. So here also inside the code you mention I plus plus and j minus minus. After swapping you have to make I plus plus and j minus minus. Okay, so this is the total step. Now as we have come here, now let's go to the next iteration and see here again the loop for a of I is less than 0. So check whether 8 is less than 0. No, it is not. So you have to stop, means in this condition here, while a of I is less than 0, I plus plus, so a of I is not less than 0, so you have to come out of this loop. Okay, you come out of this loop and you go to the next loop. Now for the next loop, check whether a of j is greater than 0. So here 7 is greater than 0. Yes, it is. So decrement j. Okay, now again check whether a of j is greater than 0. -6 is greater than 0. No, so you have to come out of this loop. So see, I and j have stopped at these elements. Now if I is less than j, you have to swap the elements. See, so swap a of I and a of j. So 8 and -6 will be swapped. Okay, and I plus plus j minus minus. So I will increment and j will decrement. Okay, previously I was here and j was here. So we have decremented j and incremented I. Now see, again in the next iteration, see, while a of I is less than 0, -4 is less than 0, so that is okay. So we increment I. Again we check whether a of I is less than 0, 5 is not less than 0, so we come out of the loop. Now again here we check whether a of j is greater than 0. Yes, it is, but I is not less than j. This condition is not satisfied, so we stop here and we come here. Now here if I is less than j, condition is not satisfied, so we go in else. Okay, and we break out of this while loop, means we come out of this code. So the significance is that, see, I has traced all the elements, j has traced all the elements, so all the elements have been checked and negative elements have come on one side and positive elements are arranged on the other side. So I has become equal to j now. Okay, and that is why we break now. We come out of the while loop. Okay, see here now, negative elements are arranged on one side and positive elements are arranged on other side, and we visit every element only once. So the time complexity is O of n and space complexity is O of 1. Okay, because it is in place. See, this can also be done using sorting. This can also be done using sorting. Positive and negative numbers, if you sort the array in ascending order, then automatically negative elements will come on one side and positive will go on the other side, but the time complexity will be of n log n. So this is the way we segregate positive and negative numbers. Hey friends, please subscribe to my channel as I post algorithm videos every day. And if you want a video on any particular topic, then please mention in the comment below. Thank you.